This is the generator building where the generator is housed and stays. This is the generator right here. This is a 240 volt, 30 amp receptacle where the power connects to the garage to the generator. I will start off by talking about this building's heating and ventilation system. In the generator building, to keep it at an optimal temperature for the generator start, I have a 250 watt incandescent light bulb on a thermostat, which will turn on at the desired temperature to keep the generator warm in the winter. And for in the summertime and while the generator is running, I have a reverse acting cooling thermostat that is tied into this 24-inch fan to draw fresh air in to cool the generator building while it's running or on a hot day. To take fresh air in, I have an automatic damper installed on the other side of the building, which will draw fresh air in from this cooler side of the building and blow any air away with any exhaust gases away from the main structure, as well as make sure to not intake any exhaust fumes from the exhaust pipe. This damper uses this damper actuator mounted on the side of it, which is powered off of 24 volts off of this transformer, which is tied onto the constant power. How the damper works, it's a 3-wire system where if it has 24 volts on 2 of the wires, it will go to fully close, and on the 3rd wire determines how far open it is if that wire has a voltage applied to it. For example, if it has 5 volts on that 3rd wire, that will open the damper to exactly halfway position, and if it receives its full 10 volts, it will go all the way open, which is how I have it configured to either be all the way closed or all the way open. So currently this has just 24 volts and 0 volts on the 3rd control wire. However, how it gets that voltage is that will only get the 10 volts to open when the thermostat decides it's hot enough in here, and that thermostat will then give not only 120 volts to the fan, but it is tied through on this receptacle that the fan plugs into this box, which houses a relay. This is a 120 volt coil relay where the 120 volt ties into the top, and it is configured as normally open. So when it has no power, the relay is in the open position, and when it receives 120 volts at the same time as the fan does from the thermostat, the relay will close, allowing this transformer right here that puts out 10 volts to travel through the relay and go to the damper to open. I will demonstrate this now by turning the set on point of this thermostat down to a lower temperature so the fan will turn on and the damper will open. That has the damper in the fully open position, so the damper is currently receiving 10 volts on the 1 wire as well as its normal 24 volts that it always has. Now once the 10 volt goes away and it only receives the 24 volt on the other 2 wires, it will go back to the fully closed position. This system draws around 3,000 CFM of airflow. That almost concludes the portion of this video about the ventilation system, though I want to show the redundancy that I have put in place in case something goes wrong. As this system provides automatic heating and automatic ventilation, there is also redundancy built in for both of those systems. That comes in the form of these alarms right here. These are just thermostats, the same that controls the heating and ventilation, where we have a regular heating thermostat for the low temperature and a reverse acting thermostat for the high temp alarm, which may sound counterintuitive being the reverse acting cooling thermostat is actually the alarm for the high temp and vice versa. However, these are tied into my commercial fire alarm system with this Honeywell addressable module. My fire alarm system that I have installed is a addressable fire alarm control panel with an addressable system, meaning that every single device uses what is known as an SLC, which is what stands for signaling line circuit. That SLC communication circuit comes out of here. It is a Class A loop, meaning it goes out on two different sides. So if it is severed in the middle, the other side can take over and you won't lose any of your devices. That SLC communication loop talks to modules such as this one right here that monitors the sprinkler system for any water flow, meaning a sprinkler head has gone off. However, that same loop will also talk to manual pull stations, as well as the smoke detectors and heat detectors. Every time it blinks, that is known as polling, where the addressable device is communicating its status to the main control panel. Those are known as points, and this fire alarm panel can support up to 198 addressable points. I currently am using around 21. 2 of those points are taken up by this module. The reason this one takes up 2 is it is a dual monitor module where it can turn the addressable data logic into conventional zones, which is just 2-wire open or closed circuit, where these thermostats are what ties in to the normally open fire alarm circuits on this module, where if one of those circuits closes, the module will recognize that and tell the panel that that has happened. For example, if for some reason our light bulb burns out or our heating system fails, the low temperature alarm will come on, which we can turn up what's considered low temperature to 25 degrees or so, and you will see that module will activate. There you can see the module has now activated and recognizes that the circuit has closed. And that gave us what is known as a supervisory at the main panel. We can acknowledge that, and this would do the same thing for high temperature. Now, it doesn't come up as a fire alarm because there isn't a fire emergency. It is just coming up as a supervisory, which just beeps at the local panel and does not set off alarms on the rest of the system. The reason it says supervisory AR is that stands for auto reset, where it isn't a latching device. Once the trouble clears, it will go back to normal. You do not have to reset the system. The high temperature alarm will do the same thing and will come up as a high temperature alarm on the fire alarm panel. Now let's talk about the safety systems that are put in place in this generator building. While we're still on the fire alarm subject, there are 2 components in here that are tied into the fire alarm system. We have a smoke detector and a heat detector. The smoke detector here, this is another addressable device where you actually set the device on the back. I can take the device down. It will put the system into trouble. There is how you set the device address. There is a 1's place and a 10's place. As you can see, the 10's place is set to 1 and the 1's place is set to 3. That makes this device address number 13 on the system. It is a fully supervised system where, because this device is no longer seen by the panel, it will put the fire alarm system into trouble, which we can acknowledge. And you can see we have smoke, photoelectric smoke detector, generator building, invalid reply, which means the system has tried to communicate to this device, though it has failed to reply to the fire alarm system. So we have smoke detection for any small smoldering fires that may start, and for anything that quickly gets out of hand, we have a heat detector which activates at 57 degrees Celsius. Both of those are tied into the fire alarm system and will put the system into full alarm, setting off all of the horns and strobes, and will give me an alert on my phone that the fire alarm system has activated. We also have emergency lighting in here should the generator fail to start automatically and someone needs to come out. This emergency light will come on automatically upon power failure and help illuminate the building, which is important because oftentimes the power outages are at night and that could be when you need to get out here. Last thing before we get into the generator itself is we do have intrusion alarm, part of the security system in this building. There is a door contact on the door, which will read the door magnet on the door itself. as well as an external siren to add to the overall siren volume, as there is another siren mounted inside the main building. Those all connect back to the main security panel, where we have our security keypad right here, and it will scroll through to say generator room, showing what zones are open, which those tie in to the security panel right here. For the generator itself, this generator is capable of putting out 8,000 starting watts and 6,500 running watts. The difference is the starting watts are the surge as your power initially comes on, and you have a spike in current from motors and induction type loads that put a large startup current, and then it will sustain 6,500 watts running, which is plenty for this building as it has a very small heating load. As last year I installed this ductless mini split heat pump, which provides cooling and heating and is very low current draw. This, however, is an inverter generator. The reason I went with an inverter generator instead of a regular generator is generators that use inverter technology put out much cleaner power and a nicer AC sine wave. The reason that's important is a dirty sine wave can be damaging to sensitive electronic equipment, and that is measured in THD, or total harmonic distortion, which BC Hydro has their own set parameters of maximum allowable total harmonic distortion. I believe that is under 3% total harmonic distortion, which a standard generator that is not an inverter type will put out a much higher total harmonic distortion, which could be damaging. Inverter generators, the actual alternator inside off the engine puts out DC current, and then the inverter turns it into AC, which has a much cleaner sine wave. This is just a portable generator, but I have turned this in to a fully automatic generator, just like what you would see in many commercial buildings for emergency power. The way I have done that is I installed a special type of module in this plastic box right here, which I will open up. This is the module installed. This is called a V6 AutoGen smart controller, and it does connect to Wi-Fi. That gives it the capability of having an app and gives it the capability to send emails of if the power's gone out and the generator started, and if power is returned, as well as any troubles if this doesn't start the generator successfully. This is the app for it. I will open the app now, and you can see that the generator is in standby mode, but the generator is off. The way this module starts the generator is with a few different electrical connections. When I installed this, I had to install some relays behind this cover, which tie into the start switch and the stop switch. I have two automotive type relays installed behind there, which they are tied into these three wires. These are what control those relays. We have a common positive and two negatives, which get grounded out when this runs the sequence that determines they need to be switched on or off for those relays. So just three connections from the relays inside of the generator. However, you can see we have many more connections than just that. We have three connections over here that run to a linear actuator, a very small linear actuator. That is installed on the choke to start the engine. That's the three wires over there, and then we just have a positive connection to the battery and a negative connection to the battery, which power this device. But how does this device actually know once the generator is running? That is done with this cord that is plugged into one of the output receptacles on the generator and tied on to the far left two terminals right there, which that is pretty much the entire connections to the generator. But then how does this actually know when the generator needs to start? That is done with these connections right here, pin 10 and pin 12. Those are configured when they receive 12 volts, the generator will start. Since they're just receiving voltage from the same battery that supplies the thing, without this relay, they would constantly be receiving 12 volts, which would basically always be telling the generator to start, which wouldn't work. So they need to be ran through this relay. This is another 120 volt coil relay, and I am switching 12 volts with it. The 120 volts comes in right here, which is active right now. It's currently receiving 120 volts, that's why this little red light is on. When it has 120 volts, this relay will open up the contacts, and this wire and these wires will not be making contact with each other. However, when the 120 volts goes away, when it drops out in a power outage, this relay will deactivate and it will close in, connecting this side to this side, then giving this module 12 volts, telling the module it needs to start. So this 120 volts ties into the BC Hydro line side of the transfer switch, side that is only on BC Hydro. That leads us right to the automatic transfer switch, which none of this has any use if there's not the automatic transfer switch that will transfer the load between sources. The last component in here, as this does draw constant 12 volts off of the generator's battery, is I have this little 12 volt charger. It's just a 1 amp charger that keeps the battery charged. I have a clip on the positive and a clip on the ground or the negative as the battery, just to keep it charged up. The generator power goes through that yellow cord out the side of the generator building. Same with this black cable here, which is that power that goes to the module to tell the generator when to start. They both go into that hole right there. After that point, they run through this box and through this conduit into the side of the main garage building right there. And they go into this wall right here, into this box, which is mounted just below the electrical panel. Mounted in here is known as an automatic transfer switch, which is a set of contactors that will switch between different power sources. In my case, the two different power sources are regular power and our emergency power. The regular power being provided by BC Hydro, and the generator power is coming off of the generator, which is only on when the power is out. Once in the initial cover, we have the actual transfer switch right here, which we can take the cover off of this guy as well. And in here you have the actual transfer switch itself, which may look complicated, though it's pretty simple. Right here is the load side of the transfer switch. This is your one hot, your neutral, and your other hot. Then coming in right here, you have your power from BC Hydro, your hot, your neutral, and your other hot. And you can see that this contactor is pulled in right there, versus this one isn't. This one's pulled in because right now it's powered off BC Hydro. There's a set of contacts in there that when this pulls in, it will connect each side to each other. So right now the power is coming from BC Hydro and going out on the load side into this panel. However, you can see this side is not pulled in and it is left in the open position, meaning that these wires are not connected to this other side. This side up here and this side over here will always be connected together because there are jumpers going between. It's whether the contacts are open or not which decide what power source it's coming from at the bottom. Which is extremely important that this is here and in place and never closes two at once, or it could kill someone. The reason it's so important and so dangerous if you don't have it is if the generator power is on and this contact was closed in at the same time as this contact, your generator power would backfeed BC Hydro. BC Hydro uses a 25,000 volt phase to phase system, 14,400 volts phase to ground, where it then stepped down a transformer to 120 volt phase to neutral and 240 volt phase to phase. However, that transformer will do the exact opposite thing if you backfeed it, where it will step up 240 volts into 14,400 volts, which could kill a lineman that is not expecting there to be power, that is working on the lines trying to restore power in a power outage. That's why it is extremely important that this is installed and working correct. It also is important that it is here to make sure that your BC Hydro power never connects to your generator power, as this male receptacle would then become live with 240 volts, and you can see anyone could easily touch that. So how this operates is if the power goes out, this contactor will let go and it will disconnect, and once the generator power is there, this one will close in and then send generator power to the output. Basically, this just selects between generator power or BC Hydro power and will only send one to the output and does not allow them to ever be connected together. So this is not only electronically interlocked where it won't allow them to both be in at the same time, but there's also a metal bar in between, which physically will not let both contactors pull in at the same time. There's a small board on the side here which controls some of the functions of it and gives it a time delay that is adjustable should you want that. I have it set at 20 seconds. How that works is once the generator is running and putting out power, this will recognize that there is now power on the generator input, and after 20 seconds of that power being present, it will then transfer over to that generator power. Gives the generator a little bit of time to warm up and get to speed before slamming on all of the load of the building. And then as soon as generator power is lost, it will go right back over to utility power. But how does the generator actually know when to start? I showed you where the 120 volts ties into that relay out there. That is coming off of right here, which is tied onto one of the hot legs of the BC Hydro side. So this right here is where it connects to this white wire, which makes its way out to the generator where it ties into that relay. I have a fuse installed in here as this is only 14 gauge wire, but this circuit could be fed up to 50 amps and the wire would overheat if something happened before the breaker would trip. That's why we have an inline fuse right here, which is fused at I believe 3 or 4 amps. So should this wire lose power, the generator will start. Something to look for is this red light mounted on the outside of the generator building is tied into the generator's power and will illuminate when the generator is running to show that the generator is supplying power. In 32 seconds, that is the length of time that the power is out, and during that time I do have battery backup systems to cover that time delay. I have battery powered emergency lighting such as this exit sign, as well as multiple of these battery powered emergency lights which come on instantly. I also have UPSs or uninterrupted power supplies that are mounted up in the ceiling. Here is one of them. Which you can see this currently will power everything for 244 minutes under the current load. This supplies power to a few different things. Some of those are Wi-Fi access point, network switch, as well as some of the security cameras to make sure that some of the security cameras are always active even in that slight time of the generator starting. I have a few of these UPSs around this building. The fire alarm system also has battery backup. The security system also has battery backup, as well as the door access control system, which is the fob system to let you into the building. This also has battery backup. However, it's not in this panel right here. It is in right here, 12 volt UPS, which you can see this also has a battery in here to make sure that the door access system never goes down. There is also another UPS that powers the computer, as well as another UPS in this back corner powering some equipment too. So with all of those systems in place, the power will never go out in this building. All the equipment will never lose power, and as far as general use things such as receptacles and your regular lighting, that power outage can only last around 30 seconds until the generator kicks in. I will now simulate a power outage. I have a couple cameras mounted. I have one on the transfer switch here. My main camera view will be right here, which will show the emergency lights covering the time period before the generator starting, and you will be able to see the fire door will shut when it loses power. I will now go into the house and turn off the breaker that is feeding power to this building. This building is now being powered off of generator power. Now that we're powered off of generator power, you can see that this contactor has now pulled in, so that means we're powered off of generator, and the BC Hydro contactor has let go to make sure that you don't get any backfeeding. Green indicator light on the side shows that we are powered off of generator. And here is the generator running outside. Our power indicator light is on, showing that the generator is running. You can see the damper and ventilation hasn't turned on yet because it's not hot enough in there, though it will shortly once the temperature comes up from the engine running. Right now the generator is in eco mode. If we turn that off, the RPM will come up. I usually leave it in eco mode to save on fuel. The only time you wouldn't want it in eco mode is if you're running heavy loads that are switching on and off abruptly, such as when I'm running my welder. I will run it not on eco mode. You can see your volt amp that is currently pulling around 600, not too bad at all. If you turn the heat on, that will come way up because it's a big incandescent light bulb. So anything that is fed from this building will have power outage emergency power, such as all the backyard outdoor lighting, which some of it is on this building, as well as this light pole that I installed right here to help illuminate the yard. This gazebo has power, as well as this tower that is built over here. I put this in a few years ago, and this also will have power in a power outage, as well as this shed here. So this shed is now also being powered off of generator power. We also do have fire alarm system in this building with a manual pull station, alarm, as well as a heat detector. This should give me around 12 hours of runtime on generator at 50%, though usually the generator is ran much less than 50%. Usually we're not over 20% of the generator's fully rated load, as the heating load of this building is very efficient with the heat pump as well as all LED lighting. The load is never too much. The only load that puts significant load on the generator is the hot water tank, which does not turn on very often. So we should realistically get around 16, 17 hours out of the generator. And you can see that the cooling system has just came on. It has now opened up those dampers at this end, as well as the fan is running on this end here. I will now shut the generator back down by restoring power to the building, and you will see how quickly the power will transfer back over. I will run all the same camera angles of the switch back over to BC Hydro power. Okay, I will restore power now. That concludes my video on the automatic generator setup.